about to leave, already packing. Come with me, I'm not really asking. We'll get away to a place where we don't know. About to see the world in action, what we can be, life with no distractions. We'll get away, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out. Die with my own doubts. Be free with me. Let's go, let's be free with me. Be free. Not looking back, eyes on the freeway, Bonnie and Clyde, a classic cliche. We're on the run, this is what we waited for. Take my hand, we'll make it somehow. We can't miss out. I'm done living life with the lights out. Die with my own doubts. Be free.
Good afternoon, it's Jim here. Hang on, let's get the right format for the start of this session, shall we? There we go, that's better. Got the wrong one there. Welcome to our I'm just looking at the thing. 1, 2, 3, 4, 5, sixth AQA A-Level Geography live revision blast. Last week we were looking at the water cycle. This week we're looking at the carbon cycle, and I'm joined today by Catherine on the left and Joe in the middle. And Joe, I think you've put together most of this fantastic session. Do you want to give us a lead off in terms of what kind of things we're covering? And then we've got lots of activities to get through with yourself and Catherine, so we'll crack on.
Yeah, we definitely have. Good evening, geographers. As Jim said, we'll be looking at the carbon cycle tonight. We are going to do a range of activities from true and false, crack the code, bubble quiz, some really challenging geography to get you thinking and your brains working. Please engage in the chat. You've been really, really good in previous sessions at having a really good guess. And for the majority of times, you've been spot on. If you're watching this on repeat, obviously pause the video and use it to help you with your revision notes.
I suppose you get a bit of extra time, don't you, on repeat, on replay? You can pause the video and take all day to think about the question. Whereas, as Catherine was saying last week, the students in the live lounge, the live chat, are really under time pressure today. So we wish them well with all of these activities. Right, should we make a start then? Let's go for it.
Brilliant. Okay, so we're going to start with me, and we are going to do some true or false questions. So on the slide, you can see a statement. You just need to put true or false in the chat. So the carbon cycle is an open system, true or false? Okay, brilliant. So you've got a couple of ideas coming through. Just give you another few seconds. Okay, let's have a look. Okay, so it's false, only because when we talk about the global carbon cycle, then it obviously is a closed system. No carbon is actually leaving any of the Earth's spheres. Right, can we go on to the second one, please? So, carbon can only be found in solid form, true or false? Let's give you a few seconds, see if anyone knows this one. Okay, well done, Brogan. So we've got false and Rebecca. Okay, you're on fire tonight, Jim. Okay, let's have a look. Brilliant, it's false. Now, most of you will obviously think of carbon as a gas, carbon dioxide, but it can actually be found in liquid form as well. Okay, but there needs to be an intense amount of pressure for carbon to be found in a liquid form. So it has to be very hot and it has to be under high pressure. So next one. So a carbon sink absorbs more carbon than it releases. So think about what a carbon sink is. Answers in the chat, please. Okay, brilliant. Someone straight in there. Well done. Okay, just give you a few seconds. Okay, let's have a look. So yeah, that is true. So it's basically where more carbon is taken in than what is released over a period of time. Well done. Let's have a look at the next one. So a carbon source releases more carbon than it absorbs. So answers in the chat, please. Okay, so people going with true to start with. Let's have a look. So yes, the clue is obviously in the word source and the fact that it's where carbon is being produced and sent up into the atmosphere in most cases. Okay, let's move on. So the primary source of carbon today, so in current times, is from within the Earth. True or false? A little bit harder, this one, because maybe it's something you don't necessarily cover as a specific idea within class. Yeah, exactly, Jim. It's not sort of very typical, but it sort of gives that general context. So we've got people going with false. Okay, can we see the answer on that one? So the key word there is today. Okay, so where most of our carbon comes from is inside the Earth. However, if we're not talking about today and we're talking about the origin of carbon, most of the Earth's carbon is thought to have come from when the Earth collided with a planet the size of Mercury 4.4 billion years ago. So whilst its initial source comes from other planets, today all of our carbon does come from within inside the Earth. Okay, sorry, Jim, you got that wrong. Let's move on. Okay, so I'm going to pass over to Catherine now. We're going to have a go at some crack the code and then we'll come back to me later. Thanks, Catherine.
Okay, thank you, Joe. So let's have a little think now about the global carbon stores. So you've got the carbon stores there. Remember, we're talking about carbon as well, like we did last week with the water cycle, thinking about the systems approach. So we have carbon being stored in certain places and we have transfers between those stores. But let's have a little think now about their sizes. And Joe has given you a little bit of a hint in those last set of questions, so that might maybe help you a little bit with this. So we've got there those different spheres. Can you put them in the correct order from largest to smallest? So you don't have to write out the whole word. You just need to write the letter code. So just putting those letters in order. So starting with the one where you think you've got the most carbon and then working down to the smallest. Okay, so let's see in the chat box your thoughts starting to come through. See how you get on with this. So you're having a think there. Right, okay, so we've got one suggestion down already. Let's see some more. So we're thinking from the largest store of carbon, and then we're working our way down to the smallest. Now, I learned something from Joe here, because Joe put this activity together, and then I had a little look at it, and I didn't realise that we could call the soils the pedosphere. So I've never used that term before. So I think that was really interesting to have a little look at that. So it shows I've been teaching for 27 years and I'm still learning stuff all the time. So brilliant to have that terminology there. So let's see. So we've got someone else. Yes, we've got here some different answers coming up. I think maybe Jim, maybe we should have a little look now and see what the answers are. Right, okay, so remember in the true and false, when Joe talks about, where are we getting our carbon from, and it was the Earth. So, we've got the lithosphere actually as a massive store of carbon. And then you can see we're going through there. A lot of you thought the hydrosphere was the largest, and you were almost right. So well done. And then we've got the pedosphere, the cryosphere. So, of course, that's the ice, and then the atmosphere, and then the biosphere. So really well done for giving that a go. And you got a lot of ones there that were close, but maybe just go back over this after the session to make sure you're really securing that learning. Okay, back to Joe again.
Okay, excellent. We're going to have a go at 10 multiple choice questions. And I want these to be really quick fire. So quick skimming over the answers and answers in the chat so we can move on. So first one is, how does plant respiration affect the carbon cycle? Does it A, have no impact? Does it B, take in carbon during the process? Or C, add to the atmospheric store? Okay, really quick, some people on this. It's going to give you 3 seconds. Okay, a couple of different ideas. Can we see the answer on this one? Okay, so it's C. It adds to the atmospheric store because plants release the carbon during this process, okay? Remember, this is respiration. A lot of you will be thinking of other processes which may come up in these multiple choice questions. Okay, can we go on to number 2? So, another process for plants. How does photosynthesis affect the carbon cycle? Does it reduce the atmospheric store, which is A? Does it add to the atmospheric store, which is B? Or does C, it have no impact? I feel most of you will understand this one a little bit more. It's definitely more of a focus in class. Fantastic, straight away, loads of you coming through with that. Okay, let's have a look. Let's see if you're all correct. Okay, yes, so it's A. It reduces the store because it takes in the carbon dioxide for the process of photosynthesis. So, can we go on to number 3? How does decomposition affect the carbon cycle? So that idea of the breaking down of dead organic matter. So does it A, release carbon into the pedosphere and atmosphere? B, reduce the atmospheric store? Or C, take in more carbon during this process? Fantastic. So people tend to be going with A. Give you a couple of seconds. Okay, let's have a look at the answer for this one. Yes, it is A. Well done. Okay. So remembering that anything that was once living contains carbon. So once it dies and obviously decomposition occurs, it will release the stored carbon back into the soil, often where the dead organic matter is. And then it could go into the atmosphere. Technically, it could go into the hydrosphere as well if there is runoff. Right. Number 4. How does combustion affect the carbon cycle? So think about what we mean by the word combustion. So does it A, have no impact, B, taking carbon during the process, or C, add to the atmospheric store? Brilliant, Brogan. I think you're constantly answering as one of the first. Well done. I can see the same names. You're really giving it a good go. And I know what Catherine said, it is more challenging, but you are getting a lot of these right. Well done. Okay, let's have a look. Fantastic. So you were all right. It is C. Okay, so combustion is the burning of carbon, releasing that up into the atmosphere as a gas. Okay, can we move on to number 5? So this one's a little bit trickier. What is ocean carbon sequestration? Okay, so is this process where the ocean can't take in any more carbon, which would be A? Or is it B, where the ocean releases carbon? Or is it C, where the ocean takes carbon in from the atmosphere? Amazing, people straight in with that. I'll give you a few seconds. I think you're cheating, Jim. Fantastic, let's have a look. Brilliant. So yes, when something sequests, it goes into something. So it's where the ocean will take carbon in. Okay, so it will either be diffused into the ocean water or it will be taken in by organisms within the ocean, such as phytoplankton. Okay, can we move on to number 6? So which type of weathering plays the greatest role in the carbon cycle? All of these weathering types are important. One of them is more dominant. Okay, which one do you think it is? Okay, a few of you going with B on that. Okay, just give you a couple more seconds. Okay, everyone is agreeing with B. Let's have a look. Fabulous, Brogan, for contextualizing that as well. Yep, so it is chemical weathering. Obviously, mechanical weathering, okay, the process by which rocks are broken down through things like freeze thaw will crack rocks and release some carbon. Equally, biological weathering will have an impact, but chemical weathering, particularly through the process of carbonation and acid rain, what Brogan said, is the dominant type of weathering that can remove carbon from the rocks and release it mainly into the hydrosphere and pedosphere. So, number 7. So what role does weathering play? I think I've just given you a clue on that one. So we'll do this one really quick. Does it have no impacts? Or does it B, take in carbon during the process? Or C, release carbon? Yeah, now obviously I've just gone through a little bit about the different types. So well done. I think even without me going through that, you would have probably done that really easily. Let's have a look. Yeah, so it releases the carbon that was stored inside carbonate rocks. So number 8. So what is the slow carbon cycle? Okay, so there is a name given to the carbon cycle when it is slow. So is it A, where carbon stores are influenced by changes on a daily basis? Is it B, where carbon takes between 100 and 200 million years to move? Or is it the movement of carbon from the ocean surface to the floor? Brilliant, really quick again. Let's give you a few seconds on that one. Okay, fantastic. All of you going with B from what I can see, so let's have a look. Yes, it is B. So it's that really slow movement of carbon between the stores, okay? And particular, the role of the lithosphere here is key. So where we will get carbon sequestration, you'll get marine organisms dying, falling to the bottom of the ocean. We will get carbon then stored inside the ocean floor, and then eventually Okay, it may reappear due to volcanic activity, but it takes a long time for that process. Okay, can we go on to number 9? So the opposite one, what is the fast carbon cycle? So is it daily basis? Is it between 100 and 200 million years? Or is it the movement of carbon from the ocean surface to the floor? Okay, excellent. Answers coming through. Brilliant. Well done. Let's have a look. So yes, the fast carbon cycle is very much to do with the processes that occur regularly. So things like respiration, photosynthesis, etc. Okay, let's do the final multiple choice then. So number 10. So which of these scales, so when we talk about size of areas for the carbon cycle, which of these does the carbon cycle operate at? Is it A, all of them? Is it B, plant and sea scale, or C, continental? So think back to when we did the water cycle and we looked at different scales that we could consider the water cycle in. Brilliant, some really good answers coming through with everybody going for A again. Okay, you can see a C as well. Let's have a look. Okay, it is all of them. Unlike water cycle, where it's very specific in the spec, that they want you to talk about the hill slope, they want you to talk about the drainage basin. We do obviously study tropical rainforests, but we do talk very globally about the carbon cycle, but technically you could apply it to any scale. Okay, fantastic on those, well done. So if we can pass over now to Catherine for the physical ocean pump.
Right. Okay. So let's have a little think now at what is happening in the ocean. So think about this pump that we're thinking about here. We're thinking about the carbon cycle, and we're thinking about this movement of the water in the ocean. And also, we're thinking about the carbon as well. So this is quite a tricky one. It's going to take you a bit of time to read these. So have a little read through of these. And what you need to do now is put the numbers into the chat box. Okay, so we've got numbers 1 to 7 there. Have a little think about which one you are going to go for first, and then put the numbers into order. Let's see how you get on with this really tricky one. Going to need a little bit of thinking time for this one, I reckon. Wonder who'll be the first to give this a go. We've got some names that are definitely getting familiar now for getting answers in, but I do think this one needs a little bit of thinking. And then it'd be brilliant to have a little look at what order you think. Oh, great. Yeah, I think starting with 6 is a good starting point there. Thinking about the high latitudes, carbon dioxide in the atmosphere diffusing into the ocean surface. Oh, we've got a couple of answers now. Yeah, great stuff. A lot to think about here. A lot to think about. Let's see if we can have a couple more people having a go. Right. Well, it looks like Jim thinks we might already have a right answer. So shall we have the big reveal to see? Oh, I think that we definitely had some close ones. Did we have one absolutely right? I think we did. Excellent. Yeah, really well done for that. So we've got in higher latitude areas, the carbon dioxide diffusing into the ocean surface. And then that's happening because of the difference in pressure between the air and the water. But the water is colder, and as the water is colder and therefore denser, so it sinks. And that sinking water is moving the dissolved carbon from the surface into the deeper ocean. And then we've got, of course, the movement of the ocean water moving back to the lower latitudes and upwelling. So you might have heard of this term before, the ocean conveyor, which is linked in with this. Carbon will be released into the atmosphere. And then you've got the surface ocean water being warmed and being carried poleward, and the cycle keeps repeating. So really interesting when you start looking into this. And of course, you've got some lovely links as well between topics. And remember, with A-level geography, it's a really good idea to think synoptically. So we're looking here at the situation with carbon in the ocean, but of course that is going to be very linked as well, this movement of ocean currents, to the coast topic, if you study that topic, which I think we're going to be looking at next week in this session. So really well done for that, and well done to Joe for really nice activity there. And back over to Joe now.
Okay, we're going to do a few rounds of the bubble quiz. So if you're not familiar with this, this is where you will get a question or a statement, and you will get 4 answers. Okay, what you've got to do is read over the answers really carefully, because the correct number of answers could be 0, it could be 1, it could be 2, it could be 3, it could be 4. Okay, and there is a range through these different ones that we're going to do. So don't just think that because the first one might be 1, for example, or 2, that the others are going to be the same. So let's have a go at the first one. Okay, so what I would like you to do is not just tell me how many answers there are. I would like you to tell me which letters are correct. So in the chat, which of the following provides evidence of links between the water and carbon cycles? So is it ocean temperatures increasing, ocean and atmosphere exchanges, volcanic eruptions, and glacial storage? So tell me which ones you think. Brilliant, already some answers in. Let's give you a little bit of time. See if anybody thinks any differently. Okay, should we have a look? Okay, so it's all of them. Now, obviously, the ones that I can see on the screen have missed out C. Okay, now the reason why there is a direct link between the two is obviously because of the production of water vapor that could occur as a result of steam from volcanic eruptions, and the fact that that water vapor will then be a greenhouse gas and it will contribute to global warming. So there is a link there. Okay, they're not necessarily relying on each other during that process, but there is still a definite link. But I can completely see why the people in the chat went for the other 3, which are definitely more obvious. Right, let's go to the second one. So how does the carbon cycle influence evaporation rate? So does it A, lead to drier areas reducing it? B, higher temperatures increase it? C, warmer temperatures reduce it? Or D, an increase in rainfall causes a rise? Have a think about this one. Answers in the chat. Be careful with the higher, warmer, increased, drier comments. Make sure you're reading them correctly. Let's give you a few more seconds. Okay, so we've got some people coming through with those. Okay, a little bit tricky this, and I think it's just because of the phrasing, really. Okay, very similar sort of ideas in each one. So let's have a look. Okay, so it's actually A, B, and D. Okay, so drier areas will reduce it, in the idea that you've not got that water store as a supply of water for evaporation to take place. B, higher temperatures increase it. So obviously warmer temperatures will increase the rate. and then an increase in rainfall causes a rise. That one is more an indirect cause, in the sense that if there's an increase in rainfall, there's on the which then will lead to more evaporation. Okay, number 3. So you've got to think about dynamic equilibrium, which we talked about last week, and the idea of positive feedback. So which of these is a positive feedback for both cycles, the water and the... So is ice melt releasing carbon from the tundra positive feedback? Is it positive feedback? Is an increase in clouds reducing temperature positive feedback? D, ice melt cools oceans, increasing storage. So that positive feedback. Just going to give you a little bit of time. This one's quite tricky. And I know from my own students that sometimes people can get a little confused with this idea. Give you a few more seconds. Okay, let's have a look then. Okay, so if we think about the ones that it is not, okay, afforestation is negative feedback. Remember that positive feedback is amplification of the cycles, is a sudden change and increase. And when we look at carbon cycles and water cycles, it's often that sudden increase, particularly with carbon, into the atmosphere. Okay, so reducing the amount of trees is going to cause a significant shift of carbon, for example. Increasing clouds will reduce temperatures. So what you're doing there is you are reducing climate change as a result of those water and carbon cycles. So you are bringing it back into balance after global warming. And then the ice melt cooling the ocean means that the ocean can sequester more carbon. Okay, so all of them are negative. The ice melt releasing carbon is the positive feedback. So anybody who got the A, that's brilliant. And some of you got A but mentioned another one as well. So it is that idea that carbon is stored within the cryosphere and it is released. So there's that sudden change, that amplification. Okay, let's have a look at the next one. So I've mentioned what negative feedback is. So this one might help you a little bit more. So is it A, more CO2 increases photosynthesis? Is it deforestation for B? Is it temperature rise leading to a longer growing season? Or is it D, increased heat leads to ice melt? So which of them are negative feedback? Okay, these are tricky. Just going to give you a few seconds. Okay, we've got some ideas coming through. Okay. Right, shall we have a look? Okay, so A and C are the correct answers. So negative feedback is bringing dynamic equilibrium back. It's bringing it back into balance. So some scientists would argue that if there's more CO2 in the atmosphere and it's warmer the atmosphere, there will be increased plant growth, so there'll be more photosynthesis, so it will take in more carbon, which will bring the balance back. Temperature rise means a longer growing season globally for certain areas, in particular higher latitudes, so that again will lead to more carbon being taken in. Okay, brilliant. Let's move on. Okay, we're going to move back to Catherine now, where we do a quick categorise.
Right, thank you very much there. And I think that was just really valuable, Joe, because it's often positive and negative feedback I find my students get confused on. And the idea that positive feedback, it makes it sound like it's going to be a brilliant good thing, but it's not necessarily. So that was lovely to hear those explanations. So what we're looking at now, we're categorised. We've got 2 categories here, natural and human. Causes of change in the carbon cycle is what we're looking at here. So you just need to have a think about which of these would you put under natural, which would you put under human. So let's start the clock. Right, okay, so let's see now into the chat box. Let's see which ones you think are natural and which ones you think are human. So just write the numbers down so we can see which ones you think go under which of these headings. Yeah, so type down natural and type down the numbers you think are natural. Right, so let's have a look at these. So, for example, look at hydrocarbon fuel burning and think, is that natural or is that human? Right, all brilliant. We can see some answers coming through now. Lovely. Some of them are more straightforward than others. There's a couple of ones in here that maybe you might get a little bit stuck on. Right. Oh, and there we go. Right. Okay, so let's now have a little look and see what the answers are. Right. Okay. So we've got there a lot of them going under the human category. Now, one of them that's actually interesting is wildfires, because wildfires, as you may have learned about if you studied hazards, they can start naturally because of lightning strikes. But unfortunately, nowadays, a lot of them are being created as well by humans, but it is still mainly a natural thing. But it is a bit of a concern that we're starting to get more human activity leading to wildfires. So wildfires and volcanic eruptions there for natural. But look at how much people are doing. Look at how many things humans are doing, which is affecting the carbon cycle. So many different aspects. And one that sometimes students get a bit confused about there is rice growing there. But of course, that is going to be very important. And that's going to be very significant in some areas. You've got massive amounts of rice being grown commercially, so grown for business reasons. So well done. Well done, those of you that gave that activity a go. And let's hand back to Joe again.
Okay, this is just a reminder that obviously within this unit, you would be asked to study a particular type of tropical rainforest. Most students will study the Amazon because that's what's in most of the textbooks, but I'm sure some of you will do either Indonesia or Malaysia as well. Okay, so we've not got time to look at this in more detail, but obviously you need to study that yourself. We're just going to do some quick true or false. So in the chat, please, true or false to this statement. Low carbon energy sources are the only technological solution to climate change. True or false? Okay, let's get these in really quickly. Okay, you can see a couple of answers coming in. Okay, let's have a look. Yep, it is false. And the one thing that I always think of when I think of technology is I think of carbon mitigation. So things to do with absorbing the carbon storage, things like that. They are still technological. Okay, obviously low carbon energy, renewable energies are really important. Okay, let's go on the next one. Carbon trading schemes reward countries that increase emissions. True or false? Okay, do they reward countries that increase emissions? So straight away we're in there. Okay, so most of you going with false. Let's have a look. Yep, you're correct. They will reward countries that reduce emissions. Okay, that one was quite an easy one. Let's have a look at the next one. So carbon capture and storage is an example of sequestration. So we looked at ocean sequestration earlier. Do we consider carbon capture and storage to be an example of that? Okay, true or false? Okay, so people going with true. Okay, brilliant. Let's have a look. Yes, and it is true. So sequestration can be natural in the oceans and in other types of source such as peat bogs but it also can be manufactured and caused by humans to try and balance out the increase in carbon emissions in the atmosphere. Okay, let's move on. So carbon capture can happen naturally as a result of reforestation and afforestation schemes. True or false? Okay, brilliant. Excellent. You're really, really good at these, true and false. Got some really good basic knowledge. Brilliant. It is true. Well done. Okay. And the Paris Agreement's aim is to limit global temperature rise to 3 degrees Celsius compared to pre-industrial levels. Okay, so is that correct? Is that statement correct? True or false? Okay, so I can see somebody going with false. Oh, well done, Brogan. Okay, fantastic. Let's have a look. Yeah, brilliant. And Brogan got it spot on. It is 2 degrees C. Okay, it'd be great if we could get 3 degrees C. Okay, but 2 degrees C is their expectation. Okay, let's move on. So we are done. So we'll hand back over to Jim. Just to make you aware, geographers, that over the Easter holidays, we will be having 2 sessions on A-Level coasts, as you can see on the slide there. So next Wednesday at 11:30 and then the following Wednesday at 10. Please make sure that you watch live, or if you've not got a chance, that you go back to it, because it will give you a really good insight of the whole spec. Okay, but well done and thank you for joining in.
Yeah, that was brilliant. Fantastic. Great session, Joe, Catherine. I loved quick fire, wasn't it? But we still had time for some fantastic explanations there as we were going through, which I think is a big part of these sessions. And I'm just looking at that schedule there. So I would be, if I was an A-level geographer, I would be setting my alarm clock for 11:28 next Wednesday morning, I reckon. Don't you think? Unless, of course, you're doing another subject like psychology or sociology or economics. They may have the 10:30 slot or the 9:30 slot. So take a look at the link there to see if there are some other subjects that you're studying as well, if you wish to get involved in some of the other live revision blasts over the next 2 weeks. There are lots of them coming up. Fantastic session. Hopefully you enjoyed that. If you're watching live, if you did, give Catherine and Joe the traditional YouTube a thumbs up. And that has 2 effects. Firstly, it makes Catherine and Joe particularly happy at the end of a fantastic session, but also it helps YouTube suggest this live stream replay and session to other students who have been looking at A-level geography topics, in particular the carbon cycle. So it'll suggest it as a possible thing for them to watch too. So that will be really helpful. If you want an alert when all the new sessions are added, because we're going to be adding all these new sessions to YouTube first thing tomorrow morning, subscribe to the channel. That way you'll get an alert as and when the new sessions are added. And I think that's about it. I think, Joe, Catherine, is there anything else to say other than what amazing students we had on our live session tonight, of course? Oh, we've lost a bit of sound there. That's cool. Don't worry about it.
Yeah, they did amazingly. Well done.
Yeah,
well done, everyone.
Superstars.
Yeah, a great session as well. I mean, I say it's hundreds, thousands of people will be watching this on replay, but I tell you, the live students tonight were amazing. Their answers were fantastic. So hopefully on replay, you can do as well as they did. I must admit, I did have a go at the questions, and it does help to have the PowerPoint in front of you to see what the answers are coming up. But I did my best. So don't do that on the replay. Have a go without the PowerPoint in front of you. Superb stuff. Right, we're going to sign off now. We're looking forward to seeing you all next week for our first A-level session on coastal systems and landscapes. But for now, have a great Easter. Enjoy your weekend and see you later.